In this video, we will study about the rotational motion. So the first thing we will do the analogy between the linear and the rotational motion. Here, the stick as a whole is rotating, but the red part of the stick is in the circular motion. Then the first term for the red part of the stick is the linear displacement, which is measured in meter, and the angular displacement of the object as a whole is theta, which is L by R, and L is the linear displacement, which is represented by S, and we can find the relation between linear and the angular displacement. The second formula we can study here, the linear velocity and the angular velocity, and the angular velocity can be found by the analogy that angular velocity is equals to change in angular displacement upon time taken. There we can put the value of angular displacement, which is s by r, and 1 by r is taken out as it is constant for the given situation, and ds by dt is the linear velocity. From there we have found the relation between linear and the angular velocity. The next term is the analogy between linear acceleration, which is change in velocity upon time taken, and the angular acceleration, which is change in angular velocity upon time taken. Again, by analogy, angular acceleration is change in angular velocity upon time taken. We can put the formula of angular velocity, which is v by r. Again, 1 by r is taken out as it is constant, and dv upon dt is the linear acceleration. From there we have found the relation between linear and the angular acceleration. Next term is the mass, which is used in the linear motion, which is a measure of inertia. But in rotational motion, the inertia can be measured by the term moment of inertia. Moment means we will combine the inertia with the radius, and here we can find the formula of the moment of inertia is mk square, where k is the radius of gyration, which can be calculated by the formula as shown here according to the diagram. Here all the different points are having different moment of inertia, which is a unique point of the rotational motion. Next term is the analogy between linear force and the angular force, which is called torque or the moment of force. Again, by analogy of F equals to ma, torque will be I alpha, and by substituting the value of I and alpha, we will be able to found the relation between torque and the force, and which is F into R. Next term is the linear momentum and the angular momentum. Linear momentum is mass into velocity, so the angular momentum is I into omega. By putting the values of I and omega in the formula, we will find the relation between linear and the angular momentum, which is L equals to PR, or L vector is equals to R vector cross P vector. Next, we will see the analogy between linear work and the angular work done. Linear work done is force into linear displacement, so as the angular work done is torque into angular displacement as shown. And next is linear kinetic energy and the angular kinetic energy. By analogy, linear kinetic energy is half mv square and the angular kinetic energy is half I omega square. Thank you.